Hello everyone, it's Wilson here. Today I want to talk about this limits at infinity. So as you can see that x is approaching infinity and we have this rational function and we want to find what this rational function is approaching to. Okay, so first, if you directly plug in a large number into the x, right? So if you just think about the form of this function, right? So let's just analyze the form for this function here. Okay, so what happens is that we have a 1 at the top, and then we are going to be having a quadratic at the denominator, right? So as you can see here, it's going to be something like this. And then, so we get a 1 at the top. And then, so if you look at this form of the function, and if you plug in the big number in there, you see what's going on here? We have infinity square. Well, that's a large number square, and then subtract 12 times a large number. And that's already an indeterminate form. So we actually have no information about what's going on here, right? Even though the top is a 1, but the bottom, it's infinity minus infinity. So that's a form, that's an indeterminate form. So we cannot really apply the limit law directly as you if you try to apply the limit law by taking the limit of this, taking the limit of that, taking the limit of this, and taking the limit of that, and try to compute the limit, that's not going to work. Okay, so it's not correct to just plug in the infinity in there. Okay, so let's erase that. We don't need that anymore. Okay, so now how do we do this problem? What we can do is this. So first, you can see that there was an x square right here. What we can do is to factor out the x square from all the terms in the denominator. And then you may say, this negative 12x does not have an x square in it. How do you factor it out? We can still factor it. We just will put it as the fraction. So if we do that, then it's going to look like this. So the 1 is still at the top, right? So we do not need to do anything to the 1, right? So we factor out the x squared. And then you may say, why x squared? Because that's the highest power for the x for um, the denominator. That's the leading term, right? So that's the leading power. So now if we factor the x squared, then what do we have left inside the parentheses? We will have a 1 right here because x squared times 1 will give us back the x squared. And then continue. We have minus. Now, if you pull out the x squared here, you got to figure out something that when you multiply by x squared, it will give you this negative 12x. And what do we get here? We get a negative 12 over x. Then you may say, how do we get that one? Just think about this. If you take x squared, you distribute this x squared back into the stuff inside the parentheses, x squared times 12 over x, and then you can see that the x squared and the x you can reduce, right? You can reduce the fraction by reducing the x, and then you are going to lower this power by 1, which will give you just the x. So negative 12 over x, that's how you factor the x squared. That's what you have left in there. And then following the same idea, then you are going to be getting, right, the 35 over x squared. And as you can see here, when you multiply the x squared with the 35 and the x squared, you can cancel the x squared. You are still going to get the 35 back, right? Okay, so that's the factorization here. And then you may say, now what? Now what, right? Okay, so now let's think about what happens when x is approaching infinity here. So if x is approaching infinity, let's look at each quantity separately and see what's going on. So we are going to do it on the side right here. So if you just look at the one on the outside, okay, so if you're letting x approach infinity and then the x square, you see what's going on here? Instead of writing that, I think it will be actually faster to write it like this. So I'm just going to say that as x is approaching infinity, then what's going on? Let's look at the x square right here, which is this factor. X is approaching infinity, so x squared is also approaching infinity, so that's simple. And then now the 1, we don't need to worry about the 1 because there is no x involved. Next one is the negative 12 over x. Let's write it down here. Negative 12 over x. And that's approaching, what is that approaching to? Now let's think about this. X is getting larger and larger. in the positive direction. So if you take the 12 divided by a really large number, then imagine that you take 12 and divide by 1,000, 10,000, 1,000,000, 10,000,000, and 100 millions, and so on, 1 trillion, right? So and so on. So it's that quantity is actually approaching zero. And of course it will be negative, but we are not going to worry about the sign right here. It's approaching zero. Okay. So now what about the next fraction? The next fraction is the same situation here. We have the 35 over x squared. And so you know that if x is approaching infinity, then the x squared, as you can see here, is approaching infinity. And 35 over something that's getting larger and larger, that's also approaching zero. Okay, so from there, and as you can see that the x squared is getting larger, the 1 is just staying as a 1. Those two fractions are approaching zero. So now you actually will turn this limit into a new limit problem. Okay, so what does it look like? The 1 at the top is still just the 1 at the top. And then what about this x squared right here? This x squared is still just the x squared. And then now the stuff inside the parentheses, it's going to be the 1, right? And then what about this thing? This thing is just what? This thing is just the 0, right? So you have the minus, and actually I can, instead of including the minus sign, I can just erase that, right? I don't need to worry about the minus sign. I can put the minus sign right here, and then that is approaching 0. So you can see that that's the green 0 here. And then what about the next one? The next one is the red 0, but you know that they're both approaching 0. So see what's going on here. You actually get a new function here. I mean, a new limit problem here. It's 1 over x squared times, that's just 1, right? That's approaching 1. Okay, so what happens when x is approaching infinity? This x squared is approaching infinity. That means you have 1 over something that's really large. And so what is the answer? That answer would be 0. Because if you see it here, you can actually see that that's actually approaching the form of 1 over what? 1 over infinity, right? And so see what's going on here. If it's 1 divided by a big number like those ones, it's approaching 0. So the answer is going to be 0 for this one. Okay, so that's it for this problem. If you like this video, please give me a like, subscribe to my channel, and share my videos to others. It will give me support to make more videos. If you have questions or have a topic that you want me to talk about, please leave me a comment.